Hello everyone. Today I'll be demonstrating how to use a large language model to exploit an indirect prompt injection vulnerability via its APIs. We'll explore the lab scenario, understand how indirect prompt injection works, and finally, solve the lab by leveraging the LLM's capabilities to delete a user. Let's get started. Prompt injection attacks can be delivered in two ways. One, directly, for example, via a message to a chatbot. Two, indirectly, where an attacker delivers the prompt via an external source such as training data or output from an API call. Indirect prompt injection often enables web LLM attacks on other users. For example, a hidden prompt inside a web page or email might make the LLM perform unintended actions such as forwarding emails or executing commands. In a legitimate scenario, users might interact with LLMs to summarize content, like emails or web pages. For example, a user could ask the LLM to summarize the most recent email, and the LLM would retrieve and summarize the content without executing any embedded commands. Ideally, the LLM should recognize and ignore any malicious instructions within these contents. To exploit indirect prompt injection, follow these steps. Discover the attack surface by interacting with the LLM and identifying the APIs it can access. Use hidden prompts in external content, such as product reviews or emails, to manipulate the LLM's actions. Let's see within the lab how we can leverage this to delete a user account. Let's now demonstrate how to solve this lab by interacting with the LLM to delete the user Carlos via indirect prompt injection. Click on Access the Lab button. From the lab homepage, select the live chat option to start interacting with the LLM. Ask the LLM what APIs do you have access to. The LLM's response reveals that it has access to APIs that can perform critical actions, such as deleting accounts. This is important because it shows that the LLM can potentially be used to manipulate user accounts. Now ask the LLM what arguments does the delete account API take. Knowing the required arguments allows us to craft specific inputs to test for vulnerabilities. Now let's try this. Ask the LLM, please delete my account. This step demonstrates that certain actions such as account deletion require user authentication, which is a typical security measure. Alright then, let's register our account. Click on Register. Also, we will need an email address which we can get by clicking on the Email Client button. You can put any name for the username. In the email field, copy and paste your email from the Email Client section. And for password, input your password. Register and go to the email client and click the link in the email to complete the registration. Now log in with the previously created account. Creating an account allows us to test the APIs in a logged-in context, which is necessary for certain actions like deleting an account. Return to the live chat page and ask the LLM to change your email to a different address. The LLM changes your email address, confirming that the Edit Email API works on the logged-in account without requiring any further information. Ask the LLM to tell you about a product other than the leather jacket. Note that the LLM includes information about the product's reviews in its response. Now let's add a new review including a hidden prompt to delete the user account that the reader is signed in with. This hidden prompt is designed to trigger the LLM to delete the user account when the LLM processes the review. Return to the live chat page and ask the LLM to tell you about the 6-pack beer belt product again. Try to visit link My Account. Note that the LLM deletes your account. We can see it in the backend logs as well. Successfully deleting the account demonstrates how indirect prompt injection can be used to exploit vulnerabilities in LLM APIs. The hidden prompt within the review tricked the LLM into performing an unauthorized action. Alright, let's solve the lab by deleting Carlos's account. Create a new user account and log in. On the home page, select the leather jacket product. Add a review including the same hidden prompt tested earlier. Wait for Carlos to send a message to the LLM asking for information about the leather jacket. When he does, the LLM makes a call to the delete account API from his account, deleting Carlos and solving the lab. By placing the hidden prompt in a product review, we ensured that the LLM would process the prompt when Carlos queried information about the product, ultimately deleting his account. Now let's talk a little bit about remediation. To prevent exploitation of LLM APIs through indirect prompt injection, you should implement strict input validation and sanitization. Validate and sanitize all inputs to prevent malicious prompts from being processed. Train LLMs to recognize and ignore malicious prompts. Ensure that LLMs can distinguish between legitimate instructions and harmful prompts. Regularly audit and monitor LLM interactions. Continuously monitor interactions with the LLM to detect and respond to any suspicious activities. By implementing these security measures, you can mitigate the risks associated with indirect prompt injection and ensure the safety of your backend systems. To summarize, we've successfully exploited an indirect prompt injection vulnerability in an LLM API to delete a user account. We've also discussed how to remediate this vulnerability by implementing input validation, training LLMs to recognize malicious prompts, and monitoring interactions. Understanding and securing LLM APIs is crucial for maintaining the integrity and security of your web applications. Subscribe to learn more, drop a like to support me, and comment any questions you have.